Thank you, Marcy, and good afternoon. First, I want to say I'm very pleased to be invited to speak for a few minutes this afternoon. This is my first opportunity to be a part of this workshop and conference, so this is all new to me. I just do want to say that some of the presentations I heard this morning on the Good Samaritanship, on volunteerism, I just really felt that that was a very positive effort from a humanistic perspective to how to use the good of mankind to try to get something accomplished. So I was really impressed. Hadn't heard too much of that in my career path. Hopefully you won't hear me doing any coughing like I've been doing these last 2 days. And no, it's not the uranium cough. It's that Dad was the last person in the family to catch the little respiratory thing from the rest of the kids and the wife. So endure it with me. So we'll get started here. And this is a little bit about it's going to be the Moab UMTRA project, but to tie it into the theme of this conference, it's about uranium legacy, the mining and the reclamation in southeast Utah. And we're in juxtaposition to the San Juan Mountains. We're more the canyon country, the desert, but hopefully we'll have something that'll be interesting to you, whose most focus appears to be in the San Juan Mountains here. But the Moab site really has an interesting history and background. And Charlie Steen was one of the, I would say probably one of the more famous American geologists in the last 100 years. And he, in the early 50s, just with not much money and a little Jeep and a family and a worn-out little drill rig, went out in the country of southeast Utah, and he took all the AEC, the Atomic Energy Commission, the guidebooks, and the best from the scientists and geologists on where to find uranium. He just threw that all out the back door of the Jeep, and he went with his own convention and his own theories. He came out of Texas, by the way, with just a BS degree at Texas, El Paso, and he discovered the fabled Mi Vida mine over in the Lisbon Valley, and that's what kicked it off. It was primary ore, it was high-grade ore, and that's what started the big frenzy way back in the early 50s. And then Charlie and his partner started the Uranium Reduction Company, and so they put the mill right there near Moab, right next to the Colorado River, as was the practice in those days. Is you need water, you need some flat ground, and you need to have access to the mines that it's easy to get the ore to the mill. So this is why this happened. There wasn't a lot of forethought into the environment in those days. And then Uranium Reduction Company did very well. They had both an alkaline circuit and an acid circuit over the years. And the Atlas Corporation then bought the mill from the URC, and they operated. They bought it in '62, and they went to '84, and so they operated for many years. So the product yellowcake, so U308, it went primarily to the AEC. Some of it in the later years went to the utilities, but primarily to the AEC. And then in '98 they filed for bankruptcy with the low price of uranium, and they didn't have a big bond. And here's a picture in 1986 before we go. Oftentimes they're called ponds, not piles, but it's because there's lots of water involved with the processing, and then on top of all the tailings, it's basically ponds or lakes. So common occurrence everywhere in the world where there's uranium mill tailings. This is a picture in 1966, right 750 feet from the river. And so it's 3 miles north of the town of Moab. It's a 480-acre site. 130 of those acres are covered by uranium mill tailings. And now DOE acquired this project in 2001. So with Atlas going bankrupt, the big decision was, well, who's going to manage this cleanup? And because of most of the product went to the federal government over those past decades, the decision was made in Congress, let's have DOE be responsible for the cleanup and make it a Title I UMTRA site. And so it turned out we did a environmental impact statement. We wanted to involve the public, involve other agencies, both local, state and federal. We wanted to make sure that we had a lot of input before we made a final decision. And so we used the NEPA process to help us make a good, informed decision. And so we decided to relocate the tailings, and we have a recorded decision that says that that's going to be the preferred alternative. So it's actually the largest uranium mill tailings pile in the world to be relocated. And again, it sits, one of the reasons why the decision was made to relocate, it just sits 750 feet from the west bank of the Colorado River. And so a little bit of this regulatory setting is the awareness of the potential health effects that are associated with the long-term exposure of mill tailings, uranium mill tailings. It really all started to culminate in the 70s. And even before that, I think the medical community had some insight that there was some health effects. But by the time it got to the states, were able to bring this to the politicians, and they said, you know, that's really, we need to do something. And then also, after the years when the federal government quit having price supports for uranium, then the price really dropped, and especially after 3 Mile Island incident, the price then really went down when the reactor industry slowed down, and the federal government wasn't buying uranium. And so when that low price of uranium, a lot of these processing mills, they just closed shop. They just basically left the gate open in some cases, and there's lots of stories, you've probably heard of them. And so, and that pushed Congress also to look at the passage of the Uranium Mill Tailings Radiation Control Act, UMTRCA of 1978. So that is the federal law, that's the act that gave the Department of Energy the authority to clean up the tailings. It also said that EPA, you would promulgate the standards for the cleanup. They're primarily prescriptive standards. There is some little bit of flexibility in there, but they're not risk-based. They're very prescriptive, based on a lot of health physics authors that were able to say at these thresholds and below, we should be safe. And so groundwater in the earliest days really wasn't a consideration. So in later years, the standards were remanded to include groundwater cleanup. And then that happened in 1995. And so again, the ownership came to DOE in 2001. We're responsible for the cleanup and the reclamation. And it's called the Moab UMTRCA project. And the NRC is the regulator. The state really plays no role in this. Other than just we have very high trust relationship and good communications, but that they don't get too involved. We just try to keep them informed on our progress. And so the EIS that I talked about in the record of decision, it was completed in 2005, and primarily it said we will relocate the tailings away from the Colorado River up to Crescent Junction, which is 30 miles to the north at the toe of the book cliffs. And for transportation, we're going to use rail. There's an old rail line there, and we just thought, with a lot of input from a lot of people, we just thought the best decision, let's use the existing rail line. Union Pacific runs that rail line, and we won't have to put tailings trucks on the highway and compete on the highway with residents and the tourists. And to do active groundwater cleanup was a part of this, and any vicinity properties that we would remediate those to the EPA standards. By the way, the soil cleanup is based on radium. It's a 5 and 15 curie per gram limit. And here's a feature of the site right here. Don't have a pointer, but you can see the rail loadout area. It goes into the mountain, so there's a tunnel right there. So we don't have much room on the hillside. Here's the pile. This was basically probably taken approximately a year ago. We have to condition those tailings, even though it's out in the desert. If you drive by, it looks like they're dry. They're not dry. We have 3 types of materials within tailings: sands, and transition material, and then slimes. Industry term is very fine grain, almost like a bentonite. So we want to try to homogenize those materials together, get a uniform consistency, uniform moisture content, about 17%, before we load it and ship it to Crescent Junction. There's arches across the road, so Our neighbors is Arches National Park, just the crown jewel of the park system in the country, and very good neighbors. We do everything possible to make sure that we're good neighbors to them. And there's the Colorado River, a picture of our well field, and I'll talk about that in a few minutes. And then Moab Wash that comes right adjacent to the mill tailing site. And even though it looks fairly innocuous, it does have the potential to have a lot of energy during times of flooding. Next slide. So here's the process here. We load we condition the tailings, load it in the containers. We ensure that the outside of the container is clean. We scan that and swipe them. We use a statistical method. We take it up on the hillside, load it on the train, and take it to Crescent Junction. And then up at Crescent Junction, we unload the container. We take it to a dump ramp, and we dump that, load it into a mine truck, and haul it out to the disposal area, and then compact it according to specifications in our remedial action plan, and then the train goes back to Moab that night. And the geology here, I won't spend much time on it. It's very interesting geology. Actually, we get geology and engineering students from colleges from all over the world that come and visit us every year, lots of times repeat universities. And there's a lot of structure here. There's a lot of normal faulting. It's just fantastic for type sections. Look at stratigraphy and faulting where you can really get up and close and try to understand some of the Colorado Plateau type of features that we have. So we've been doing that for years, but then what we had was a rock fall in November 18th, a major event that was really unplanned. It came from the top of the mountain. It was very big. And when that happened, go to the next slide, then here's a picture of it right here. You can see the scar, and it came right down on the rail bench. So now I'm not taking any geology students or engineer students up there. We just stayed down in the area near the highway, and we look up there. And we go to the next slide. Here's a picture where the circle is. So about 4,500 cubic yards of material came down. No one was hurt. We had a big gantry crane close by. It was slightly damaged, but this really shook us to the bone. This was not anticipated. It would happen during the life of our project. We knew this hazard was there, but we just didn't expect this to happen. It's really on a reoccurring interval of every 50 years, 30 to 50 years that this would happen. And so that it happened late last year. UP came in and cleaned it all up. So what we did is our highest priority is to ensure that we don't get anyone hurt on this project. And so after we cleaned it all up, we were down for a while. We said, what do we do? Well, we looked at all the different technologies, and we went with a South African technology of a radar system. Here's a picture of it. It scans 24/7, and it gives us a very, very detailed picture of the whole hillside, the 2,300 feet, every 3 minutes, and it can detect sub-millimeter movement. So I can't spend too much more time on that, but it's working very, very well for us, and it's given a lot of confidence that we know when the next one's going to come. Now, groundwater plume, we have two constituents of concern out of all the different types of contaminants associated with mill tailings at Moab. It's just two that are really elevated above background, and that's ammonia and uranium. And really, ammonia being the bigger driver from a constituent of concern perspective because of its effects on the aquatic life in the river. And since we're close to the river and the river acts like a sink for most of the year, then it's something that we want to try to address. And so we started early on in the project with extraction wells, and then we went to injection wells with clean water close to the river, moved our extraction wells close to the toe of the pile, and to be honest with you, it's worked very well. We knocked the concentrations down of ammonia from say 2,000 down to now the 500 milligram per liter level, and ammonia still, it's come down, but it's still around 1 milligram per liter ammonia. Next slide. And here's a little bit of a picture. I won't spend too much time on this, but we pump the contaminated water up to an evap pond. It's a very effective way to get rid of this water. We use it for dust control up there. It's smart versus getting clean water for dust control out of the river. We To date, we've extracted 221 million gallons of contaminated groundwater, and from a mass perspective, 846,000 pounds of ammonia, 4,350 pounds of uranium. This are in the evap pond. Later this year, this evap pond is going to be decommissioned and all dried out, taken up to the disposal cell and placed. And then our fresh water, we run it through a filter system and we create a hydraulic barrier, and that's worked very effectively at keeping the groundwater conditions down low. Next slide. So current activities with the future in mind. Tamarisk has been a big problem for us. We have removed almost all the tamarisk at the 480-acre site. We have done a lot of re-veg. This is not mandated, or this isn't necessarily dictated, but we think it's a smart decision to start this re-veg early. As soon as we have these off-pile soils cleaned and verified clean, let's start with natural vegetation, Fremont cottonwoods, some salt-type grasses because they're very alkaline soils, willows, and this helps with dust control, and aesthetically it's very, very pleasing. It's been successful to date. We're also getting some phytoremediation going on when these willows get their roots down in that ammonia. It's been very positive. The bird song, I think the ornithologists call it, is just tremendous down there this type of year with the amount of wildlife that's coming back in. Next slide. So the end state and vision, land ownership. We will eventually transfer this site. This has not been determined. It could go to the county, could go to another federal agency, maybe DOE will hold on to it for a while, but the thought is we want to do what's best with working with the local community and the other government agencies. We want to leave it in a park-like setting. I've used this term for years and years out there in public meetings. I think most people agree with me on this, but there's lots of ideas, and so we encourage people to have ideas, and there is a Mill Tailings Project Future Use Committee. They act as a quasi-organization to represent the community's interests, and they've actually been active in putting together a little document about what the site could look like when we're done cleaning it up. And so all these answers have not been determined yet, but so far I think everybody's going down the same road, rowing in the same direction. Next slide. So up at Crescent Junction, this is a disposal cell. This is going to last for 1,000 years. So this is the legacy. This is the product that we're, other than the clean site at Moab, this is the product that we're going to leave for the future generations. 5,200 feet long, 2,400 feet wide. We excavate it in phases. Here's a picture of it. We already have 2 of the phases that are excavated. They're almost, the first cell's completed, the second cell's almost completely filled. The tailings depth is 50 feet up there. It's 25 feet below grade, 25 feet above grade, but with this footprint, the size of this, it's a very subtle feature. It is an umptress-style cover. It's 10-foot multi-layer cover with rock on top. It actually blends in nice aesthetically. If you ever drive by, you'll see our big maintenance shed. It's white. Yeah, I didn't really want white, but that's what happened. But if you look at that disposal cell, it about blends in as far as a perfect tie with a shirt. If you look at the book cliffs and look at those colors, that's just me talking, but hopefully you'd agree with me. Next slide. So status. Currently, we're shipping 104 containers a day per train, one train, 4 days a week, Monday through Thursday. Our full train is 136. Within the next 2 weeks, I hope to be back at the 136. We've been methodical and taken our time at just a stepwise fashion to get back to the full train because, again, we just don't want to rush anything and get anyone hurt. Next slide. So I'm going to just have a couple more here, and I want to end on safety because that is truly our highest priority on the project. That's our passion, and that's what drives everything that we do on a daily basis. So early in the project, we had safety lunches where we talked about safety, and we gave out awards. We encouraged good, safe practice. We awarded people all the time. We continued to do that years later. And we created a contractor safety committee. So the workers have their own committee. And they might invite me and they might not. They can have it without me or without. And it's working well. Actually, they like me coming, but if they ever to say, Don, we don't want you there, I'm say, okay, I understand. That's how it's supposed to work. And then the effect on the safety during the American recovery, and Reinvestment Act, ARA, those years we grew to 400 employees almost overnight. And it's hard to have a good safety culture when you grow that fast, that big. So we had a few relatively minor safety incidents, but it was something that we had some lessons learned that came out of. Safety conscious work environment is something that we really push hard. We want employees to always raise safety concerns. They should always feel free to be able to bring up anything on their mind, whether it's negative, positive, or what have you. And we have safety questionnaires, worker engagement, employee concern program, and to date, I can say, and we don't ever brag about this because tomorrow's a new day, but we have 2.3 million safe work hours as of May. Days away from work, restricted transfer, total reportable cases rates, both of these have been at 0 for almost 2 years. So very proud of that. And lastly, here is our website. If you don't want to jot down the address, you can Google Moab DOE, and we're really very proud of being transparent. Everything that we produce goes onto our website, and so it should be a good document, and you can always call me anytime. My number's on the website. Thank you very much for having me.